Jai Hind. Welcome back to chemistry class. Now today, in last day, what we have discussed about that different temperature and different properties. Today what we'll discuss? Today we'll discuss about the different law of chemical laws. Okay. Now, first of all, here you can see that what we have the law of chemical combination. We have law of chemical combination. Now, just suppose here you can see one I'm just write one normal reaction I'm giving. Suppose A, and when react with a B, it is forming AB. We know this is known as a combination reaction because already we have an idea of the chemical combination reactions. Okay, the combination reactions. Because we know the different type of reactions are there. I'm just taking an example of combination reactions. Now, when any chemical reactions happen, it follows some rules. It follows some basics law, and that law is known as law of chemical combination. In our early stage, or you can say in the previous classes, you have read about the two law of chemical combination. Number one was the law of conservation of mass, and second law was the law of definite proportion. Now today we will discuss about the five basic law which govern the chemical combination reaction or chemical reactions. So let's start that what are the chemical laws. Today we will discuss one by one with the example so we can easily understand this one. Okay, so let's start with the first one, law of conservation of mass. Obviously, law of conservation of mass was given by Antony Lavoisier. Obviously, just see, it is the around 18th century, you can say. It is the end of the 18th century. That time he has given the law around the 17, 18 something. So what is the law? Law is telling that law of conservation of mass states that a matter cannot be created nor be destroyed in a chemical reaction. What does it mean? It does mean normal meaning is suppose a chemical reaction occur before the reactions and after the reactions mass will be the same. Mass, there is a mass constant, mass will not change, and that is the called conservation of mass. Suppose one example here we have taken that we have a sulfur and we have a iron. When we are mixing them and heat them, it is forming the iron sulfide. It is forming iron sulfide. Now just count their mass. Okay, sulfur has a, we know the sulfur has a mass 32 gram and iron has a mass 56 gram. So I suppose I am taking that 1 mole of sulfur and 1 mole of iron. When they react, they will form that 1 mole of ferrous sulfide. Ferrous sulfide. Now just count that. Oh, what is the amount of ferrous sulfide? It is forming the 88 gram product. Similarly, sulfur is obviously in the reactant side. If you are summing up that what is the total mass on the reactant side, in the reactant side mass is the 88 gram. In the product side mass is the 88 gram. So according to the Anthony Lavoisier, the law of conservation mass, this one, and obviously always remember whenever any chemical reaction occur, it should be follow law of conservation of mass. Now suppose I am taking an example. I have simple example I am taking that I have C carbon plus O2. It is forming the CO2. Now can you call these reactions follow the law of conservation of mass? So let's start. Carbon has a mass 12 gram and oxygen has a mass 16 into 2, that is the 32 gram. That is the 32 gram. And what is the mass of the carbon dioxide? We all know that carbon has a 12 2 into 16, that is the total mass will be the 44 gram. 44 gram. So in the just see in the reactant side we are getting total 44 gram and in the product side we are getting 44 gram. So what does it mean? That it follows the law of conservation of mass. Similarly, one more example we can take. The example I can say that suppose formation of ammonia. Formation of ammonia. If I have nitrogen, if I have obviously whenever you are writing equation, you have to write down the balance equation. Otherwise, the law of conservation of mass you cannot match, and that is why we are balancing any chemical reaction. So we have the 2NH3. We know this is the known as the formation of the ammonia. Now, what is the mass of the ammonia? Nitrogen, you know that one atom of nitrogen has the mass 14. So 14 into 2, that is a 28 gram of nitrogen. When react, it is forming 28 gram of nitrogen react with the 3 into 2, that is the 6 gram of hydrogen, and it is forming that 2 into 14 plus 3, that is a 34 gram. Ultimately it is coming 34 grams. So you can see in the reactant side and the product side it is matched, it is balanced, and that is the law of conservation of mass. Sorry, in another word what we can say that before the chemical reaction, after the chemical reactions, mass should be equal. That's the law of conservation of mass. Now going to the next part, next law of definite proportion. Also this law you have read. This law is proposed by French chemist Joseph Proust. Obviously, you can see the picture I have given here. So what does this law state? This law state that a given compound always contain exactly same proportion of element by weight. What I am saying again, I am repeating the word. A given compound always contain exactly the same proportion of element by weight. And just to give you an example, Proust what have taken? Proust taken that cupric carbonate as an example. He has taken two cupric carbonate. One is for natural origin, another was for synthetic. Now, what he has found that the both the natural sample and the synthetic sample has equal percentage of copper, equal percentage of carbon, equal percentage of oxygen by weight. I am telling again, I am repeating by weight. So what he has proposed that okay, he concluded that whatever the source, whatever the source of the compound, but this compound should contain same proportion of element. I am just giving one more example. Suppose I have water. I have water. So if you are taking this water in India or USA, that doesn't matter. The water formula will be H2O. And what is the mass of hydrogen? What is the ratio of the mass and oxygen here? The mass of hydrogen is 1 into 2 and mass of oxygen is 16. So what is the ratio? So I can say that on the basis of mass, the ratio is 1 is to 8. And it is following in all places. It follows in all places. Okay, so that is the law of definite proportion. This law is telling that whenever the compound is there, whenever you are getting a compound, this compound has the same element with the same proportion by weight. Now, one more example I am giving. Suppose I have what I can say that I have the NH3. So NH3, what is the ratio of nitrogen and hydrogen by mass? Nitrogen has a, we know that nitrogen has a 14 and hydrogen is a 3. So the ratio will be 14 is to 3. This ratio always will be maintained. So this is the important that one law that whenever you are getting a compound, that compound exactly contains the same proportion of element by weight every time. So a very important that law has been given by Joseph Prout and it's always following the laws. Now we are moving to the next. Now John Dalton on the year of 1803, he obviously he just proposed another law which is called the multiple proportion law. What this law is proposed? This law is telling that suppose two element is there, two elements combine to form more than one compound. I'm telling two elements combine to form more than one compound. The masses of one element you have to fix. That fixed mass when attached with the other element, they follow that small whole number ratio. They follow that small whole number ratio. Again, I am repeating what I am telling. That suppose I have a two element, those who can form more than one compound. More than one compound. Now, one element you have to fix the mass. This fixed mass when react with the another element in two different compound, they follow that small whole number ratio. One example I'm just showing here, that hydrogen and oxygen, if they are forming water, then how they are forming? That H2, H plus O, they are forming the H2O. They are forming H2O. Two molecules of hydrogen, one molecules of oxygen is forming H2O. Or in very proper way, if I'm writing like this, that H2, 2H2 plus O2, I'm just writing the balance equation. So it is forming the 2H2. It is forming the 2H2O. Now if you are just getting that with the ratio, then what will be the ratio? That 4 gram, obviously by weight you have to measure, it is a 32 gram and it is a 36 gram. So what ratio you are getting? 2, 16, 18. So here you are getting, obviously we are talking about that one molecules of water. So 2 gram of hydrogen when react with the 16 gram of oxygen, it is forming 18 gram of water, because we are talking about the one molecules of water, not two molecules. Obviously here you have to divide it by 2. Now suppose I am taking another example, that hydrogen and oxygen when they are forming hydrogen peroxide, H2O2. Now what you are looking here, that the mass of hydrogen is fixed but oxygen is 32 gram and it is forming 34 gram of H2O2, that is the hydrogen peroxide. Now here you can see the mass of hydrogen fixed here, 2 gram. Now when this fixed mass is reacting with the 16 gram of oxygen, it will be formed the 18 gram of water. This is a different compound. And when react with the 32 gram of oxygen, it is forming the H2O2. Obviously the condition, different conditions will be there. Now here you just see that the what is the ratio of the oxygen in two different compounds? 1 is to 2. The definition of is 1 is to 2. This is a whole number ratio. This will be the whole number ratio. That you have to understand that what we are talking about. That law of multiple proportion is telling that if two elements can combine to form more than one compound and one element has a fixed mass where it is reacting with the other element in two different compounds, then obviously they follow the small whole number ratio. And you have to remember this is a very important law, that is called law of multiple proportion. Now we are moving to the next part, Gay-Lussac of gaseous volume. Till now, whatever laws we have seen, these laws are talking about weight, weight based or mass based, you can say. Now, Gay-Lussac on the year of 1808 gives the law that he observed that when gaseous, here you are getting that when he talk about the gases, and gases we are talking about the volume generally. When gases combine in a chemical reaction, they react to follow the simple whole number ratio by volume, and that is the very important line that this man has proposed on the base of the volume, not on the base of the mass. Okay.